In this class, we're going to talk about how you factorise a polynomial using a technique called synthetic division. So I'm going to illustrate this technique using these two examples. Now these are both polynomials, but particularly cubic functions, but this technique would work for any order of polynomial. So power of 4, power of 5. It's just that beyond a power of 3, a cubic, the process gets a little lengthy. It's likely if you're taking a polynomial class, you'll see a lot of cubics and maybe some quartics, which would be the next kind of level up. If you do end up going to a higher power, a higher order, you've got to kind of repeat the process I'm going to show you here. So you're just repeating the same process anyway. So these questions fall into two kind of categories. One is where you're given the original polynomial, so it's a polynomial function here, and you're also given one of the factors, and the other type is when you're given the polynomial but you're not given any of the factors. Generally these are a little more demanding because you've got to figure out one of the factors on your own, and we'll chat about that in a moment. So in this question here, we've been told that this is our polynomial and one of the brackets is x plus 1. When we factorise it, it's a cubic function. So essentially what we're trying to do is to find the other two brackets. That's what it means to fully factorise it. Remember that with polynomials, the highest power, the order of the polynomial, dictates how many brackets you expect to get. So we expect to get 3 brackets for this one, and the same with this one, 3 brackets. So the technique we're going to use involves making a table. It's a little bit like long division, I guess, but it's an algebraic equivalent. So we're saying that x plus 1 is a factor. That means that x plus 1, in some kind of algebraic sense, divides into this here. In the same way that we say, like numerically, 2 divides into 8. So 2 is like a factor of 8. It's the algebraic equivalent of that. What we do, we take the coefficients of these terms, so 1, 3, minus 13 and 15, and we populate our table using those, making sure that you capture the sign, so like the plus minus in addition to the number. Whatever number goes here, like a plus 1, you take the opposite sign of that. So I'm going to put a minus 1 outside the bracket. You'll just get used to doing that as part of the technique. We then pull down this first number so that whatever number goes here, it's quite often a 1, doesn't have to be a 1 though. Whatever number goes here, you just pull it down. And then whenever a number lands down here on this row, we multiply it to the outside number. So this technique will seem a little strange at first, but you just got to learn the process. So 1 times minus 1, and we put the result there. When you get your number in here, you then add it in the columns. So 3 minus 1 is positive 2. The number's landed here, so we times it to minus 1 again and put the result here. Adding those guys together, we would get minus 13 minus 2, which is minus 15. Timesing this number to that number again gives us a 15. Adding those together and gives us a 0. That's what you're looking for. This is the remainder that you've achieved, that you've got when you've divided by this factor. But the remainder should be 0. In the same way that if you divide 8 by 2, you get 4 with a 0 remainder. That tells you that 2 is a factor of 8. In the same way, we've divided this polynomial by x plus 1 by putting the minus 1 outside, and that tells us, because we got a 0 remainder, that that was indeed a factor. So that kind of validates that x plus 1 is one of the divisors, one of the factors of this polynomial expression. So that's part of the process, to validate that that is a factor. But remember, what we're looking for is to get these two brackets populated. So this part here, the other part of the synthetic division table, this is called the quotient, and it's a quotient that allows us to then complete the process. So what we do, we use these as coefficients of a trinomial, in this case, to give us 1x squared plus 2x minus 15. And what we're saying basically at that point is that our original cubic factorizes as x plus 1 and then this trinomial. Sometimes that will be the full factorization, like it won't go any further depending on the function in question. But in this case, we can factorize that trinomial into 2 brackets to fully factorize. So x, we would need a 5, we would need a 3 and a positive and a negative. So our original cubic factorizes as x plus 5, x minus 3. So that's a full factorization of the original cubic polynomial. Okay, so those questions are not too bad. If you're given an original factor, you then just work through the process and it never really changes. You can kind of self-check it as you're working through, because if you don't get a zero remainder here, then something's gone wrong with the construction of the question, or you've done something wrong in the working. So turning our attention to the second example, it's a little more difficult because we don't know what number to put outside our table. So we do know that we're going to have to construct the same synthetic division table, or the same idea for making the table by pulling in the coefficient numbers. We just don't know what number to put outside. But the way that these work is that the end number in each of your factors has got to be a factor of the number term of the polynomial. Because if you think about it, these guys are timesing together to make that number. 1 times 5 times minus 3 gives you minus 15. So each of those numbers has to divide into this number. If you get a question like this, it's fairly likely your end number will be a small number. Otherwise, there's too many factors to try. So we know that the only options would be 1, 2, or minus 1 or minus 2. You can just try them sequentially. So for example, if we say, right, we'll just try the 1. So pull down the 1, that's going to be a 1 there. Adding those to give minus 1, that's going to be a minus 1 there. Adding those to give minus 2. 2 times minus 1 is minus 2. And then they do add to give you a 0 remainder. That's kind of fortunate that it worked out like that. But sometimes if that's, say, a higher number, you might just need to work through a few examples. And you'll just end up with a non-zero remainder here if it's not one of the factors. And that's fine. You just discard it. Try the next one. For example, if this was a 4 here, the options would be 1, minus 1, 2 minus 2, or 4 minus 4, because they all divide into the number 4. Another way you can sometimes check it, especially for checking a 1 or a minus 1, is just to substitute that number into the x position and see if you get 0. Because if it's a factor, then you get a 0 remainder, or that 0 remainder can be interpreted as subbing in the x value and getting 0. So if we sub in 1, 1 cubed is 1, so it'll be 1 minus 2 times 1. So 1 minus 2 is minus 1. Take away another 1 is minus 2, plus 2 is 0. That's the other way you can check that first factor. So we now know that our polynomial g of x, or polynomial cubic function, has got an x minus 1 factor, because remember, these guys are always the opposite sign. So if we know it's a 1 here, it's a minus 1 here. And then pulling in this quotient part to form that into a trinomial as x squared minus x minus 2. Usually in the design of these questions, this will then factorize again. So we get x minus 1, x minus 2, and x plus 1 in that case. And that would be it fully factorized. So that's the technique of synthetic division. It's not a particularly difficult one. It's more difficult when you've got to figure out the first factor. Sometimes you'll be given that information in a non-explicit form. Like here it was given explicitly. You could get other information in the question which tells you or allows you to in some way figure out what this number is going to be here. Once you've got that number, or if you're just going to trial and error numbers, the process is fairly simple. Look out for the 0 remainder, and then it's just a bit more factorizing on the end. So that's how you factorize a polynomial using synthetic division.